Here, an unstretchable massless rope is wrapped around a solid disc. So, disc of mass M, other end of a rope is fixed while the disc is released from rest. Once it is released from rest because of weight, it rolls down vertically. So in upward direction, force acting is tension. So the net force mg minus t is ma. And let us calculate torque about the center of the disc. So here, since weight acts through the center, there is no torque due to the weight. Only there will be torque due to the tension, that is T into R is I alpha. So here T is tension, I is moment of inertia of a disk, this one, right? And here, since it is right, so for rolling without slipping is R alpha, here MR by 2, alpha is A by R, that is tension is equal to Ma by 2. Let us consider the first equation. Mg minus Ma by 2 is equal to Mg here is 3m by 2a. So we get acceleration as 2g by 3. Here radius of the earth is decreased. So here he is asking relation between radius of the earth and what will happen to gravity. G here is gm by r square. Here gr square is g is constant without changing, mass remains unchanged what he given. So g1 r1 square is g2 r2 square. So radius is decreased by 10% means presently what is the radius means 90%. So here it is 9r by 10. So gr square g1 g2 into 81 r square by 100 get cancelled. G2 is 100 by 81 G1. So what percentage of increase is G2 minus G1 by G1 into 100. 100 G1 by 81 minus G1 by into 100. So it is 19 by 81 into 100. 100 by 81 is more than 1. It's more than 19%. Here, so force on a conductor is calculated by using a formula L bar cross B bar. L bar is a displacement vector. So if you consider force on wire ABC, so here ABC is like this. What we consider is, we will not consider this path, we consider only displacement. So that is force on ABC will be I times AC bar cross B bar. This is along the path ABC. Force on ADC will be I times, but here displacement vector is current is moving in this direction, that is CA bar cross B bar. So we know that B cross A is minus A cross B. The force acting on two different conductors are opposite in direction. Here the minimum force which required to punch a hole of radius r in a plate of thickness t. This is the plate of thickness the thickness is t, and we have to make a hole of radius that is circular. Here, shear strength is equal to force per unit area. Force here is shear strength into area. Shear strength is given sigma. Area means this force is acting on the boundaries. That is, area will be this area. So that area is 2 pi r tax and thickness d. So that force will be finally 2 pi. He given thickness t, right? This is the surface area. In fact, 2 pi r sigma, that d is nothing but thickness. So here it is sigma pi dt, because he given question in terms of diameter. So answer, he given in terms of radius. Okay. So 2 pi rt, this is the correct answer. So a gas behaves like a puff. So here we have a, with respect to some condition, we defined ideal gas. There is a slight changes between real gas and ideal gas. For ideal gas equation, we know that PV is equal to nRT. Suppose if you draw a graph between PV and pressure, but for 1 mole of gas, that is n equal to 1, PV becomes RT. So PV by RT becomes 1. So here you draw a PV by RT. For ideal gas, PV by RT fixed 1. But as we change the pressures, 300, let us take some 600 different pressures. So the graphs, what they observed at 200 Kelvin, at different pressures, at as pressure temperature increases, so let us say it's 500 Kelvin. So this graph will be closer to the ideal gas. Still temperature increases. So what they observed is like this, which is 1000 Kelvin. So this graph is closer to the ideal gas behavior. So this is valid at higher temperatures, and at lower pressures it will be closer. At higher temperatures also closer when compared with the other temperatures. So real gas behaves like a ideal gas at higher temperatures and low pressures. Here, a coin of radius r is rolling without slipping on a smooth horizontal floor. Its velocity of center of mass. So, velocity of center of mass is 10 meter per second. So, once it is rolling, there will be velocity due to translation as well as velocity due to rotation. Once the particle here at P, like this, so this particle will have a velocity due to rotation that is at a distance of 0.5 r, that is 0.5 r into omega. So each and every particle will have a same translation velocity that is 10 meter per second. So r value is given right here for center of mass velocity, that is so this is r omega. So 10 plus 0.5, r omega is 10, that is 15 meter per second. So why this r omega is 10? Because it is rolls without slipping. Rolls without slipping means at this point is in which contact with this. So this here it is a translational velocity. This point will be at rest. V minus r omega. V becomes r omega. Right. Here it is amplitude of superposition of three SHMs. X1 here is 20 sine omega t. X2 is 15 cos omega t. X3 here is 20 sine omega t plus 217 degrees. This let us simplify. Omega t plus 180 plus 37 degrees, which is 180 plus will be minus 20 sine omega t plus 37 sine omega t cos 37 cos omega t sine 37 sine omega t cos 37 3 by 4 by 5 sine 37 is 3 by 5. So minus 16 sine omega t minus 12 cos omega t. So let us consider sine omega t like this. Amplitude is 20. Another is cos omega t. They differ by a phase angle 15. Other is minus 16 sine omega t. This direction minus 12 cos omega t. So the net amplitude towards right will be 4 meters. Where the net amplitude towards this will be 15 minus 12, 3. So resultant amplitude will be 4 square plus 3 square, that is 5 meters. Here, to find the effective resistance across AB, let us consider the points A and D are at the same potential. So right, between A and C, we have a one resistor R, which is 4 ohms. Between C and B, We have another resistance 2 ohms. Between D and B, we have one resistor 12 ohms, and between A and C and D, you have between C and D, you have another resistance 4 ohms. So these two are in parallel for 2 4 ohms. Equal resistors are connected and effective resistance will be half. So this circuit, if you redraw it, it is effective resistance here 2 ohms, 2 ohms. Here it is 12 ohms. These two are in series. So further, if you draw it, it is 12 ohms. This one is 4 ohms. So 12 into 4 by here 12 plus 4, 16. So effective resistance is 3 ohms. So induced EMF is minus d5 by dt. So this one, which is minus 10 cos 100 pi t into 100 pi, that is 0. Cos 100 pi is 0. This is cos will be 0 for odd multiples of pi by 2, which implies 100 pi t will be pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, so on. In the given options, so let us consider here pi get cancelled, t will be 1 by 200, 3 by 200, 5 by 200, 7 by 200 seconds. In terms of milliseconds, it is 5 milliseconds. Here it is 15. Here it is 25, 35. In the given options, 35 milliseconds is there. Let us consider that. So here, surface tension on the surface tension on the surface of a sphere, let us say T here. So work done in forming a bubble of radius r is T into, that is T into 4 pi r square. Now from 0 to r, it formed a one bubble of radius r. Now 0 to 3r. So work done in forming a bubble of radius 3r is T into this. T into radius 3r, so pi into 9r square, which is 9w. Here a pipe is open at both the ends. So the fundamental frequency is lambda by 4, lambda by 4. So length of the pipe is L, 2 lambda by 4. So lambda is 2L. So V here is F1 into lambda. So then in this case, F1 will be V by 2L. 3/4 of length is in water. So now, so it produces a fundamental note, that is lambda by 4, which is L by 4. L here is, because total length is L, L minus 3L by 4 is L by 4. V here is F2 lambda, so F2 will be V by L. What he is asking, F1 by F2, F1 here is V by 2L by V by L. Here when I current passes through it, 2 amperes here, so the current is inversely proportional when they are connected in parallel. It is 6:3, 2:1. So here more resistance is there. Here 2 amperes current flows. Here 1 ampere current flows. Totally here 2 plus 1, 3 ampere current flows through it. So that 3 amperes current is again distributed among 8 ohms and 4 ohms in the ratio I3 is to I4, which is 4 is to 8. So 1 is to 2. So less resistance, more current passes through it. That is 3 amperes current is distributed in 4 ohms as 2 by 1 plus 2. 2 amperes current flows through this. The 2 rods of same material have same length and area. Heat flows through them in 12 minutes when they are connected side by side. Here, connected side by side means they are connected in series. So here, rate of flow of heat Ka delta theta by L. It is delta theta by dq by dt is heat current. Temperature difference is reason for flow of heat, which is L by Ka into H. It is like V equal to IR. This is heat current. This is temperature difference. Here resistance is L by K. So both the rods are same material, means K is same. Same length and area. Length and area are same. Then the resistances are equal. So once they are connected in series, effective resistance is 2R. Then heat current, that is H, which is delta theta, temperature difference by 7. If now both rods are joined in parallel, then once they connected in parallel, effective resistance will be R by 2. So then delta Q will be delta Q by delta 2, I will be here delta theta by R by 2 delta theta. Heat flows through them in 12 minutes. Then this H is dq by dt per unit time. If it flows for 12 minutes, delta Q will be it is 12 delta theta by 2r, which is 6 delta theta by r. Now, what question is here? If now joined in parallel, then the same amount of heat produced. So same amount of heat produced when they are connected in parallel, amount of heat produced per unit time is this. To get 6 delta theta by r, you should multiply it by 3. That means when they are connected in parallel, if heat produced for 3 minutes, then we can have a heat current, same heat current. That is 3 minutes is the answer. That to send 10% of main current through galvanometer, so a resistance of 99 watt, the shunt required is. So here I current flows through it. IG current, shunt is connected, the small resistance which is connected in parallel. So shunt resistance, I minus IG into S equal to IG into 99. 10% of main current, that is main current is I. 10% of current through galvanometer. So 10 by 100 I into 99. So here it is 9I by 10S equal to, this is 10 get cancelled out. 99I by 1. I get cancelled. Yes, here is 99 by 9. 11 ohms. A capacitor stores 24 watt hour of energy. So here 24 watt hour. Energy here is power into time. The time is 1 hour. 60 minutes into 60 seconds. This many joules. At 1200 volts, then capacitance of a capacitor 24 into 60 into 60. Here it is 1200 square. It's 24 into 60 into 60. Here it is 12 into 672 into 100. 24 into 36 is 212. So capacitance is 12 by 100 farads. In terms of millifarads, so 120 millifarads.